For sample problem number 2, we've got another exponential equation based on a real life problem, and we're going to figure this one out. So we've got dye injected into a pancreas to see how well it's working, to test its function. The longer the dye stays, that suggests that the pancreas is working better. For a perfectly functioning pancreas, the amount of dye left is represented by the following exponential equation. So we've got this here. R equals I, it's not a 1 or an L, it's a capital I. R equals I 0.96 to the power of T. R is the mass of dye in grams that is remaining after T minutes. I is the mass of dye that's initially injected. Okay. What else we got here? If 0.50 grams of dye is injected, so the initial amount is 0.50 grams into the functioning pancreas, how much time would it take for 0.35 grams of dye to remain? So the remaining mass of dye is going to be 0.35 grams. And the question is, how much time would it take? In other words, what's T? T equals question mark. What's time? What's T or exponent when the R value is 0.35 and the I is 0.5? So we're going to rewrite our equation. R is going to be 0.35 equals I. The initial value always comes in front. I don't need to put that 0 on. It's a science thing. It doesn't actually change the number. It's just referring to how specific that measurement was. We had 0.96 to the power of T, and we still need to figure out what T is. So to solve this by graphing, because it is too complicated to get a common base, or to solve by systematic trial and error, we are going to break this up so that we've got the left half being y equals 0.35, and the right half is going to be y equals 0.5, 0.96 to the power of t. And we're going to graph those two equations. So I'm going to go to Desmo's online graphing calculator, or to the app if you wanted to download it on your phone. Okay, here we go. What were my equations again? They were, just gonna, so the first equation was y equals, we said that we want to know when it's 0.35. And our second equation, it's probably easier to just click there. Second equation is y equals 0.5, 0.96 to the power of t. Exponent button, t. And we're looking for a point of intersection. So even though they put a dot here, that's just where it's intersecting with the y-axis. We're looking where the two lines intersect, which is here. Okay, so at 8.737 and 0.35. So again, remember that the first coordinate is your, just going to rewrite it on the side here. The first coordinate, 8.737, is your x value, or in this case, our t value. It's this here. And the second value is always your y value. So in this case, it's the amount of dye remaining. So you will have 0.35 grams of dye remaining after 8.737 minutes, because the question specifies it as minutes. So we're going to include a therefore sentence for our final answer. Therefore, 0.35 grams of dye will remain after after approximately, because it's not exact, approximately 8.7 minutes, because I've rounded it, I need to say approximately for proper communication. 0.35 grams of dye will remain after approximately 8.7 minutes if the pancreas is functioning. Because remember, that equation is representing if it's a good pancreas. If the pancreas is perfectly fine and it's functioning the best that it can, that's when this exponential equation represents it.